Okay, let's finish this topic off with case 4. Just one more problem, one more type of partial fraction decomposition to look at. And let's see the pattern. So here's our problem, x cubed plus x squared over x squared plus 4 squared. Okay, so our non-reducible quadratic is now repeated. So there's nothing we can do to simplify this problem first that we need to do. There's no factoring in the denominator or anything. So, this is not factorable again. Since it's not factorable, it's going to stay as a quadratic. So case 4 is the denominator has repeated irreducible quadratic factor. Okay, or factors. So this is a quadratic factor, non-reducible, irreducible, and it is repeated because of the squared. All right, so let's see how we break that down into different fractions, right? Decompose it. So that would be an A over, well, we don't have any extra things here, okay? I did kind of keep this one a little simpler, I think. X squared plus 4. Oh, and it's not just A. I was getting ahead of myself, right? It can't just be A because that would be for a linear factor on the bottom. When we have a quadratic, it has to be AX plus B, okay? And then we're going to add to that our second denominator, x squared plus 4 squared, okay? This is a lot like case 2. You just keep repeating those until you get to the exponent there. And then that's just over, or cx plus d being the numerator. Okay, so it is a pretty simple pattern too. I think all the patterns, once you practice them a little, are pretty easy to learn and use. They're really similar, nothing much to them. Okay, so now that we've broken it down into ax plus b and cx plus d, let's find those letters. So start out the same. We're going to multiply by x squared plus 4 squared to get rid of all fractions. So on the left we have x cubed plus x squared, and on the right we have, use parentheses, ax plus b times x squared plus 4, just one of them, and then we have cx plus d. Oh, well, that's actually the same denominator again, so I'm actually just going to take out that parenthesis. This is not really doing anything, is it? Okay, so here is our equation that we need to tackle. Okay, and I think once again we're going to have to create a system to solve. The reason being, again, that x squared plus 4 is not convenient, right? So we could let x equal 0. I'm sure we'd get rid of a and c, but then how would we figure out what b and d were? And then how would we eventually figure out what A and C were? I don't see it happening. I don't know. So I think we have to use a system, okay? But this one looks like a pretty easy one. So over on the left, we actually have 1x cubed and 1x squared, right? The coefficients of those are now 1. And we have 0x and 0 as our constants. Okay, so I'm putting these over here so we can see what the equations will be equal to for the coefficients. Now on this side, I have to FOIL this, okay? So that's fine, just FOIL it out, So we get ax cubed, and then we get plus 4ax, and then bx squared plus 4b. Okay, that's just the FOIL of the first 4 terms there. And then this is just plus cx plus d. Okay, let's do that fun collecting of the x's. So if I make the x cubes all be blue, okay, I have an x cubed Oh, I just have one of them. It is times a. Guess I could have just, I don't even like that. I'm going to write it again. Ax cubed. Okay. And then in pink, I have plus 1x squared. Let's see if there's any x squareds to collect, right? Here's one. No. Okay, so plus bx squared. This problem is even easier than I thought. And then plus 0x. So maybe there's some x terms. Yeah, here's one, an x term, and here's one. Aha. Okay, so plus x times 4a plus c. You see what I did there? This is the x. I'm putting that out front, and then the leftovers in the parentheses are 4a and c. Okay. And then d, let's use this pretty color, is the constant terms. Oh, there's two of those, right here and here. So that's just plus 4b plus d. There's no x's at all. Okay, let's set up our equations. In blue, we have 1 equals a, right? Because the coefficient of x cubed is a, or 1. And then in pink, we have 1 equals b. Oh my gosh, this is like my favorite problem ever. Okay, now c, let's see, or x's, 0. Green, 0 equals 4a plus c. Well, that's going to be pretty easy because we already know a, so let's just solve that. 0 equals 4 times 1 plus c, so c is negative 4. Okay, and then finally, I was thinking I could get away with not moving the screen. Almost get the whole problem in. Okay, there. Let's see. 0 in purple equals 4b plus d. Okay, but we know b, so that's 0 equals 4 times 1 plus d, so d is equal to negative 4 also. Okay, I do honestly think that problem was a really nice one and really pretty easy. And maybe that's how, a lot of this case is. I need to see the little problem to be able to write my answer. Okay, so this is ax plus b, so that's just it doesn't want to write. It's thinking too much. There, finally. X, right? Because it's 1x plus b is 1, and that's over x squared plus 4, plus, and then cx plus d would be negative 4x minus 4 over parentheses x squared plus 4 squared. All right.